Okay. Let's take a look.
Yes, I can make it too. That's what I'm doing. We have like that's more than
Okay, here we go. So, recap of Unit 2. Remember we talked about the end behavior functions, and then we talked about also where it either crosses or bounces the roots, and how that comes from our equation. So for example here, if this function touches at -2 and crosses at 4, can someone help me, like, before I even look at the answer choices? We should know what factors that comes from. So like x, what would I do for -2? +2. And then for the other one, I would have x -4. Because these are the zeros, these are what makes this equal to 0, right? Okay, therefore, when you look at your answer choices, take a look. We should be able to cross off C, and that's it. The rest all have that, okay? Now, taking a look, if it bounces over here at -2, does anyone remember what we have to do to this factor if it bounces? Angie? It has to have a squared because it has a multiplicity of 2, which means it's a double root, which means we can eliminate A. So we've got either B or D. Now the difference between B and D is this value up front. If A is greater than 0, they're saying A is positive, and there's a positive in front of this whole thing. If A is less than 0, they're saying it's negative, and there's a negative in front of this whole thing. So that comes into clarifying whether this is an odd, it's odd because it's going 2 different directions, but an odd positive or an odd negative. Looking at the way this graph faces, this is an odd negative. So we know the leading term right here has to be negative. So we're going to go with D for this one right there. Okay? Does everyone see why it was D? You say okay?
Yeah.
Okay. No. You can keep them because when we do retakes, like Friday, Monday, anyone that wants retakes, like we have our quiz on Friday and then we'll have a lot of extra time so people can take retakes, and I'll tell you just pull out one and do it on the back. So don't throw these away because then it'll save us some paper. But for today, I'll leave you a new one. Okay, so tomorrow we're going to go over a take-home problem very similar to this one, another graph where things are bouncing and crossing and you're looking at your end behavior. So let me pass out and you guys can put these away. One of these to everyone. Then if you can get out your one from yesterday, it looks like this. We're going to review the answer of that one. I know you weren't here yesterday, but yesterday we started June 1st that are old common assessment, or old questions that will review us for the common assessment. You always do one as the due first, then I send you one with one from now on until the common assessment. So you can do 2 problems. Okay, so this is the one for today. Take home to try. Okay, so the one from yesterday, take a look. Oops, you can't see, the screen's frozen. Here we go. The one from yesterday looked like this. So take a look. Yesterday we talked about composition of functions f of g of x. And anyone see the eraser?
Yeah, no.
No.
have to use
Oh
a,
yeah, it's over there.
where?
I think it's in that. I don't know. Yeah.
Oh, thanks. Okay, so if we have f of g of x, or g of f of x, or f of x times g of x, we want to see if we get an even or an odd function. So for this first one, when you multiply these two, you end up getting x to the fifth plus x cubed. When you distribute this in, you would add the exponents when you're multiplying. So what do you think, Alba? Even or odd? Even if you don't remember exactly what it is, what do you think it? Even or odd? Why? Can you add these together like that? Can you add x to the fifths and x cubes? So like think about it, like can I add x squared plus x? Like if I have 2x squared plus x plus 3, can I add those two together? They're not like terms, right? So these are stuck like this, so I can't put them together. So they're stuck like that, and right now, what are they? Both of them are odd. And so the definition for an odd function was that, I have to take this off, it's really hot. I'm gonna have hot air. Was that if you plug in a negative x, if you take f of negative x, you end up with negative f of x, you end up with the opposite. And when you put a negative inside of x right here and take it to the fifth power and the third power, it stays negative. If you put a negative in an even power, it's going to go away and you'll get f of x back. Okay? So this one would be odd. For f of g of x, which one are we plugging in? This is y'all's review for next week, so join me if you're not with me. You plug in g, so we're plugging g in here, so we're squaring something that's on the outside. F is on the outside, and we're plugging in g like this, so you would have to do a box with that, and you're going to end up getting x to the sixth power, blah, 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 and you would notice that all of the exponents are even, which means if you plug in a negative, the negatives will go away, and it'll be the same thing as f of g of x. So this one is even. Last one, g of f of x, you're plugging f into g, so you've got something cubed plus something, and both of those somethings are x squareds. So we have x to the sixth plus x squared, so odd or even? Even. So our answer is going to end up being 2 and 3 end up being even. Okay? All right. Go ahead, put that one away. And we are going to move on to our unit circle now. Quadrants 1, 2, and 3 today. Tomorrow you'll have a chance to do the whole thing, and then we'll be taking retakes. So all unit circles that you have out that I passed back, if you can put those away. All yellow sheets of paper, if you can put those away. And any common assessment little half sheets you're collecting a pile of to review, you can put those away. 1, 2, 3, 4, 5. As soon as you get it, you can just start quadrants 1, 2, and 3. Everything that's shaded up on the board. sure for each one you have radians, degrees, and a point. You didn't accidentally miss a spot on there. Patterns and the like fraction pieces to roll it out and add them up if you need to figure some of them out that you forgot. Seconds. Okay, go ahead and put away any pencils. If you need a pen or a marker, let me know, but I want all those pencils away. Cool. Good. Pencils up. Okay, so for today, because there's a lot of them, what I'm actually going to have you do, if I can get all those pencils away, because I'm actually going to have you get out your own unit circle, and y'all are just going to check your own. So I just want to make sure, and I'm just going to walk around and kind of check and make sure people just have pens. And you just use your own unit circle. Y'all know how to check by now. I'm just going to have y'all check your own. You can pull your unit circles out now that we got pencils up, and just check. And then we're going to count up how many those X's, okay? Three checks for each one. Like what? Yeah, so like think though, because these should always be pi over 3, right? Like notice these are always pi over 3, pi over 4, pi over 6. So yeah, you can always, the denominators always stay the same as well. Yeah. Yeah. So think about it. So the way I remember when I forget is if you picture the triangle that it came from, right? Y is this distance, and this distance, notice, is exactly 1/2. This is 1 whole. Exactly 1/2. So the 1/2 has to be here. For this one, here's our triangle. You see the triangle? See how X is exactly 1/2? So the 1/2 has to be in the X. So you can always draw the triangle and figure it out again. Yeah. So this one should still be pi over 2. It can't be the same as this, right? Because we're getting bigger. So this is 1 pi over 2. This is 2 pi over 2, or pi. So this is 3 pi over 2. You can always like recount it out. Cool, so then just write to the side minus, however, which I know it might seem like, oh, minus like 5, but there were people that were getting -5 for quadrant 1. So -5 for 3 quadrants, like, isn't that bad if you made some little mistakes around. But out of however many you got. So yeah, so remember, like, if you find me when you miss one and you want to take it, then I'll count that grade. If not, I'm just going to use the one after, like, as the one you missed.
So
So like Alba, you missed yesterday, but I'm gonna use that one for it unless you really want to take the one from yesterday, and then you can come back and take that another time. Okay? Cool. Alright, so make a pile of those for me. Make a pile of those for me.
By tomorrow, I'm gonna forget.
But I really want y'all, you should not just be memorizing where it is, like, you can always figure them out. Like, there's no reason you should forget 270 because you can just add 90 again every time. For like pi over 3, for example, it's gotta be, this is 1, this is gotta be 2. And then 3 pi over 3 would simplify, so I can't have that one. So the next one that wouldn't simplify would, after 3 you have 4, so then 5 works. Yeah, which we never split it into fifths, so we should never have 5 on 1. We only split it into thirds, sixths, and fourths. So those should only ever be in fifths. Okay? Alright, I'm gonna grab those. Did y'all already? No, we'll go back. Any markers of mine I'm gonna take back this. Okay, y'all just put yours right there. Markers, please. That's your old one. Okay. Tomorrow we got the whole thing. Tomorrow we've got the whole circle. And Friday and Monday, you can take as many retakes as you need. Specifically on Friday is our quiz, right? And so the quiz probably will not, I imagine some of y'all will finish a little bit early, which will be a good opportunity to then be like, hey, can I take a retake really quick while I'm sitting here, and I can have you do that, okay? So we should all be good to go by the time we get to the unit exam, which is on Tuesday, okay? All right, so everyone grab your notes because we're gonna flip to page 25 and we're gonna talk through law of sines today. Tomorrow we're gonna talk about law of cosines. Okay, so we got 2 more lessons. So let's make sure we're super focused and like with me because you don't have a whole lot of time to kind of like make this stuff and figure it out because your unit exam's on Tuesday. All right, so on page 25, we did a do first. Instead of this do first, we did our common assessment review do first. But I just want to recap really quickly one more time the skill that we learned yesterday. Just waiting on a couple more people to get with us on page 25. Becky, you got your notes? Okay, so yesterday we talked about inverse sine, cosine, tangent, which was when we were solving for the angle when I give you a ratio of some sides. If you see one of these composition of functions, one where you have one like inside of the other one, we're just going to start on the inside and work our way out. So for example, if I first have inside right here that we need to find the sine of 4 pi over 3. Everyone take a look on your unit circle, or at this point, since we've almost memorized or made sure we're familiar with the entire thing, I want you to think about where 4 pi over 3 is. Try to do it without looking, because on your quiz and on your unit test you won't have it. 4 pi over 3 is over third quadrant. Okay? And again, when I'm thinking about that, y'all, like, I don't want you to just have these straight up, gotta do with me. I don't want you to think about just like, oh, where is it? And I'm just like blindly memorizing these. Think, if this is thirds, 4 pi over 3 is 1 past 3 pi over 3. What is 3 pi over 3 simplify to? Which means it definitely should be past pi, right? So I know it's got to be in the third quadrant, can't be in the second one. Okay, so I look down here and I'm thinking about sine at that point, and at that point I know it's negative, and if I think about it, it's negative root 3 over 2, right? Following with me, writing it down. I want the arc cosine of negative root 3 over 2. Let me get that number, sorry y'all. I want the arc cosine of negative root 3 over 2, which we talked about yesterday. Arc cosine or inverse cosine means now we're solving for what? An angle or a ratio sides? An angle. I want the theta. None of these markers work in this classroom. There we go. I want the theta where, which one, x or y?
X.
X, cosine is x, where x is equal to negative root 3 over 2. So now we're done with the sign, right? We're on to the outside, which is inverse cosine. So I'm looking for the angle where x is negative root 3 over 2. Remember, there are multiple places. So yesterday we learned that inverse cosine specifically is only in which two quadrants? That needs to be something you have memorized as well, Tanya. That's sine and tangent. Cosine, first and second. So we're looking at the top of the circle. Where is cosine negative root 3 over 2? Well, I see it's negative, so it's definitely over here. Which angle is it going to be? Yep.
Why are we looking for cosine and not sine?
So we already did the inside, right? We found sine of 4 pi over 3, and that was sine of 4 pi over 3 literally is equal to negative root 3 over 2. So this part is negative root 3 over 2, done with that. And now I'm finding the inverse cosine of negative root 3 over 2. So I'm finding which angle will give me x, because it's cosine of negative root 3 over 2. So now I'm taking a look. Which of these has x of negative root 3 over 2? 150? Oh no, I don't see that answer. 5 pi over 6 in radians. Okay? Okay. Yep.
What does arc stand for?
Inverse. So that's what we learned yesterday.
Okay.
So if you want to watch yesterday's video or maybe like meeting with me or come to the tutorials, I can kind of catch you up.
Is it just basically this? Is it just basically that?
But it's the same thing as this. So we changed the input and the output. Now we're solving for the angle here. We were solving for the side. They gave us the angle because that sign didn't have an inverse on it, right? Okay. All right. So moving on. Inside is y. Oh, gotcha. Yep. Yep. Now it becomes x when we want to find the inverse sign. Because that one's fine. Yep. All right. So today's lesson is on law of sines. Tomorrow is the law of cosines. Law of sines and law of cosines, just to give you like a brief overview right now, is something that we're going to be able to use now for triangles that are not right triangles. The entire unit, everything we've done, if you notice, has been with right triangles. SOHCAHTOA, sine, cosine, tangent. You can only do, we started with day 1, we said this works for right triangles, there has to be a 90-degree angle, right? So you might have been wondering, maybe, from the first day, well, what happens when I have a triangle that doesn't have a 90-degree angle? Is there any way I can find the sides and the angles, or am I just stuck, right? And you can't use sine, cosine, tangent like we normally do, because that only works for right triangles, but what you can use are a couple rules that we're about to learn. Law of sines today and law of cosines tomorrow, okay? So let's take a look at what law of sines says. So right up here it says the same thing that I just said. It says we have so far learned how to use trigonometric functions to solve problems involving what kind of triangles? Right triangles. So triangles that look like this and have a nice 90-degree angle. Then it says, this lesson will focus on solving problems that involve oblique triangles, which is a word for triangles that are not right triangles. Okay, triangles that look like this one. Okay. The most common thing that we use to solve these is the law of sines. So if you have a triangle, Dennis, here's our triangle. Notice we got angle A in this corner. Y'all looking at where I'm pointing? Angle A in this corner, angle B right here, angle C right here. Anytime we call those angles, I'm going to refer to side C. Watch me. If this is angle C, side C is always going to be the side across from that angle. If this is angle B, side B, notice is the one across. And if this is angle A, side A is going to be across. Okay? If we talk about angles and the side that is across from them, they have this relationship. The sine of A, that's why we call it law of sines. The sine of A over the side A that's across from it will always be equal to the sine of B divided by B, which is across from it, and that's also equal to the sine of C over C. So, if I know a few of these sides and angles, then I can plug them in and I can solve basically for what I'm missing. Alright, that's what we're going to be doing today. So, flip over to this satellite problem right here. I've got up at the top law of sines so that we don't forget. Basically, it's the sine of an angle over its side is equal to the sine of another angle over its side. Okay? Let's take a look at what's going on in this situation and then label what we know. Can I get someone to read this problem right here about satellites?
An Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. If the angles of elevation of the satellite from the Oak Ridge and Langley facilities are 58 degrees and 72 degrees respectively, how far is the satellite from each station?
Okay, so if we want to know how far the satellite is from each station, looking at your picture, what are they asking for you to solve for?
How far?
So which is what part of my picture right here? Which one? See this angle right here? This angle is how far it is. Which one? Yep. Side B will tell us how far it is from Oak Ridge, right? And then side A, they also want, because they also want how far it is from each station. They want how far it is from Langley as well, right? So essentially, all I'm solving for here is B and A, the sides of this triangle. When I know these two angles, and I know the distance between these two researchers at the bottom. Cool? Okay, so we have a lot of angles, and we've got one side. So we should be able to use law of sines to figure this out. Now, if I have two angles of a triangle, can I find the third angle?
Yeah.
Yeah, Jordan, what could I do if I have 58 and 72 degrees? What could I do to solve for that last angle of the triangle? Okay, so let's do that first so that we have at least all the angles. And then let's use that, once we have all the angles, to try to figure out a missing side. So let's add up. 58, go ahead and add up for me. I'm going to pick someone at random. 58 plus 72, 10 seconds, I'm going to call on someone. Let's see who the lucky winner is. I'm going to bring these all up here. Lucky winner is... Oh, I dropped it. Eileen, what'd you get?
130.
130, which means subtracting from 180, we got a 50-degree angle up here. Okay, so if we've got 50, 58, and 72, I know that the sine of any of these angles divided by the side across from it will be equal to that same relationship for another side and angle. Okay, so which is the one that we know the angle and the side? A, B, or C? C, good. For C, we know the angle and we know the side across from it, right? So we need to use that to start off with. So we've got sine of 50 over 446. We have both pieces for that one, right? Agreed? Okay. Let's use that to solve for B and A. We're going to have to do two separate problems. So, Edo, which one do you want to do first? A or B? You get to pick. B. He says let's do B first. So if I want to find B, side B means that's on the bottom, right? And on the top, I've got to put sine of the angle that's across from side B. What's across from side B? 72. So now I've got enough information where everything is numbers except for B, so I should be able to solve for B. Now there's a lot of ways that you could solve for B here. You could either use, since this is an equal sign, like cross multiplication, if people have done that. Another way that you could think about it is, if I want to solve for B, I don't want B to be on the bottom, right? If I flip this one and find the reciprocal, I just have to make sure I do the reciprocal of both sides. So for example, first, you could rewrite this as 446 over sine of 50 equals, flip this, B over sine of 72. Okay, and then how could I get B by itself? How do I get rid of the sine of 72? Multiply. So if you feel like that's an easy way to like do the algebra, that's what in my last class most people ended up, I think, preferring. And then they said B equals. And these are going to be calculator questions that are on the calculator section of your exam. So then you'll use your calculator. What setting do we need to be in for our angle? Degrees, because it's 72 degrees and 50 degrees. So go ahead and pull out your calculator, make sure you're in degrees, and do sine of 72 times 446 divided by sine of 50. And then as a heads up about calculators, next week I'm going to be getting us ready for the common assessment and making sure we all have our own. So make sure we're bringing those. You're lucky you left it in my class. Anyone got the number? You would say you multiply these two and you multiply these two, so you have sine of 50 times B equals sine of 72 times 446. And then you divide by sine of 50. And notice you get the same thing, right? Sine of 72, 46, dividing by sine. So either way. Okay, and any takers from the crowd? Because like I noticed too, I really want you to actually practice plugging this into your calculator, because you'll get to the test and all of a sudden you'll plug it in and randomly you'll get different numbers than me if you're in your calculator's in the wrong setting, it's in radians. And so we're using class now for you to be like, hey, I got something different, can you make sure my calculator is right before we get to the quiz or the unit exam. So any takers, what did we get when we did sine of 72 times 446 divided by sine of 50? Tanya. 553 point, what was it? 716. And because this is a word problem, make sure you put units. Some people in the last quiz missed points for the units. And in this case, we're talking about miles. So they literally could use law of science to calculate how far a satellite is from a laboratory. Like they do this kind of stuff. As long as they know the angle of elevation, they can figure it out. Well, yeah, what are we solving for? The angle? We're solving for the distance between this and this. How far are we from the satellite? We're that many miles from the satellite at that laboratory. Okay? Okay, we only did one of them. Now we need to do the other one. So I'm going to have you all try the next one. I'm going to use the same given, sine of 50 over 446. But if I want to solve not for B, but for A, how is that going to change? Jackie, how's that going to change this side? What could I write on this side?
So you're going to look at the opposite, which is going to be A. And you're going to look at A.
Okay? And and then go ahead and solve, see if you can follow the algebra to solve that one and find A. And then I'm just gonna rock around, and once you have it, I'm gonna check it off. So I'm gonna check that everyone actually puts it in their calculator. I'm gonna check you off. Once I check you off, you can go on to the next problem, okay? Yep. Yeah. So set up now the one for A, because now we need to find this distance. So we're gonna say sine of 50 over 446. That's 446, you don't need to solve that because I already gave it to you. What are we trying to solve for? What did the question ask? From each station. So we found this one, we found B was 500 and something miles, but now we also need to know how far it is from Langley. We need to find this A. So now we need to find A. So we're going to use the same ratio, but instead of doing sine of 72 over B, 72 in B, we're going to do 58 in A. Okay? So I'll put another one, I have it over there to the side and then solve for A. Yes, I believe, here, I'll put it up. Yep. So then you guys go on to this one. Same thing, you need to find the missing angle, and then you want to find T and you need to find S. The third decimal place. So this one right here, you can either leave it like that, that will be correct, or technically if you look at the rest of it. I think you're good. When you get it right here, so I can check you, you can go to the next one. I check everyone off by hand. Yep, that's good. That many miles. Okay. So then now go on to this one right here. And we can find the missing angle, and then we can find T and S. Okay.
What is it?
Not got it yet?
You have a calculator.
Is that many? Good. So then when you're done explaining to him, go into this one, I want you to find angle T and then side T and side S. Alright girls, what you doing? Good. And then go on, find angle T and find side T and side S. Good. So then write it down that many miles. And then make sure you have units, because on the quizzes I took off if y'all didn't have feet. So same thing, make sure on the unit test or the quiz you'll have miles. Yep. Good.
Is that always going to be sine? Or is it going to be?
Since this is law of sines, the rule is always like we're using sine. Like this rule that we learned up here is always sine. Tomorrow we're going to learn a different rule called law of cosines that you can use in another case. Okay. So in this one it says to solve the triangle, which means the triangle has 3 sides and 3 angles, and you need all of it. And you're missing right now 1 angle, and you're missing 2 sides, so you need to find those. Keep going, y'all. You're in problems. I'm gonna go here.
76. It's 180.
No, hold on. Why are you cheating? I'm gonna go watch it. I'll watch you take a quiz. So for this one, when it says solve each triangle, that means like a triangle has 3 sides and it has 3 angles. You need to find anything that's missing. So you need to find the 3rd angle, and then you need to go find both of these sides, just like we found both of these sides. Yep. S, which is side S. 63 goes with 13 over there. And then whatever this angle T is that you need to solve for will go with that side T. So just like we first found that angle 50 that we're missing, let's start finding that missing angle, okay? Let me see what we're doing over here. Good, finding the missing angle. triangle has a total of how many degrees? Good, so we're gonna add these up and then subtract from 180 to see what's left. Okay. So you can't, right here, if you start, like, which one do you know the angle and the side? Yep, so you're gonna say sine of 63 over 13. Okay, that's the one that you have to use, and then you're gonna find the one that you're missing. So now you're gonna say sine of, no. So yes, but you would have to find, you can't have both of them missing, right?
Yeah.
And so you're gonna either need to do the S one right now, because you know 51, and you can put 51 here, and then you can put S on the bottom. For T, you're gonna need to find that angle T before you do law of sines.
So now
Good. The only reason I like your answer, because on your test you'll have to go 3 decimal places, but here it actually says round is 10. So I just didn't put your correct answer.
You're 66, right?
Good, yep, so you're gonna put that in for S, and then you'll need to go find T and angle
So
T on it.
so it's sine of 63.
Yeah, because you should have a sign for each of them, right? Like law of sines, looks like that. Yeah. Y'all doing okay?
Right? Oh, okay, okay.
Good. It doesn't have feet or anything in that, but it says round to the nearest 10th, which is weird. Usually we go 3 decimal places, but it would be
So we
lower.
left that.
Oh, 6.
Whatever it is.
okay.
For S. Okay. Now for T, you're gonna do the same thing, but notice you're gonna need the degrees, right? You don't have the degrees right here. How can you find the degrees?
We don't know the length, so we do sine of 51.
So I
Good.
thought you said we're trying to find the other.
We're trying to find both, yeah. We don't know what we do.
So we just 51 or?
You're gonna do it.
You're off by a little bit.
Because they're all equal to.
So, go back to 6 and then your decimal will be the right. So yeah, your decimal is off by just a
I
bit.
already did it.
How we doing over here? We got them? Good.
Second, right?
Wow.
We're trying to find
63. So make it be 63.
See what? For the, I'm good with it.
Exactly. Yeah, like you would use the angle from ship A, 39, to find the distance between ship B and the port. Gladys, focus. I'm gonna move you. Gladys, Angie, I'm gonna move y'all. Focus. Yes, good. Okay. Keep on trucking. Did you get it that time?
So it's right. Now we just flip it, right?
Okay. Where are your, so, typing this in,
Hey.
we would have
School team.
okay, how can you find this angle?
You told me.
So now, if I want to find T and S, and I know this is the other T, what ratio do I know the angle and the side? What do I know? So see, they're like paired up with the guy across from them, like 59 and S go together, 66 and T go together, 63 and 13. Right? So do I know both? Okay, so we start with that one. So we want sine of 60 degrees, write that down. Sine of 60 degrees over 13 equals. And then which one do you want to do with S or T?
I know.
Whatever.
Because once you have
Okay,
13
S,
points,
so
you
then
can
what am I
have
S?
S.
On the bottom, you want to do sine
You can use any side now, right?
They got the same answer as I
We
did.
can still use 60, right?
Wait, what did you do
Now,
first?
good.
But it's not
I solved for S.
And you want to
What you solve for?
Already hard.
Okay, but look, right now.
Oh.
Same thing.
It-
It doesn't matter which one you do. Yes, you do. It just, it don't matter which order you
I'm
go.
talking Tanya.
Challenging you?
No, because she's getting mad because I worked ahead of her.
I'm confused.
I mean,
Oh,
that's
Yes,
time flies. Oh my gosh, did that go fast for y'all? That was a full hour?
I'm doing my work.
You're not solving for no
You're so focused. Okay, I gotta close this out so that I can get you out of here on time. Dennis, I'm gonna take it. I'm gonna take it. There's no way you just happen to be looking at the back of that chair. Seems like, okay. Okay, so listen up, and just so I can let you go. For this one, and this one, you can check any of them. I don't have that other triangle one because I was gonna skip it in my other classes because we'll be short on time in there because y'all have extra. Tomorrow we'll continue with this. I'm gonna talk about one kind of weird case with law of sines. Then we're on the law of cosines, okay? Study all 4 quadrants tomorrow. We're finally there.
Miss,
Yay!
don't need to
Yeah, thank you.